Today's daily code problem of the day is sliding puzzle number 773. If you're interested in learning how to code, check out my Discord link in bio today. So, for this problem, we have a 2x3 board. There is 5 tiles labeled from 1 to 5, and an empty square representing a 0. A move consists of choosing the 0 and a 4-directional adjacent number and swapping it. The state of the board is solved if and only if the board reads 1, 2, 3, 4, 5, 0. Given the puzzle board, return at least the least number of moves required so that the state of the board is solved. If it is impossible, we can return a -1. So if we look at example 1 right here, the smallest amount of moves we can make is 1, and that is simply going to be swapping this 5 and this 0, effectively putting the 5 here. So our board reads 1, 2, 3, 4, 5, 0. Perfect. Yummy. So if we look at example 2, however, we can notice that no matter how many moves we make, it's not possible. Why did my thing just get so thick? There we go. So, I mean, we could try moving 4 here, 2 here, 3 here. I don't know. But yeah, it's not going to work, right? Because no matter how many moves we make, we'll never be able to get 5 on this side of 4. We can never swap these two effectively while maintaining everything else's place. If we look at this bottom example here, it is possible to effectively solve our board. We can follow this. Basically what we're going to do is we're going to take our board, move 5 here, move 4 down, and then so we have 0, 1, 2, 4, 5, 3, and then we're going to let's see, what's the next move? Oh, we move 1 here, so now 0's here. Let's see, I think we're going to move 2 here, we're going to move 3 here, and then boom, we have it solved. So 0 is going to be here. This is going to be 1, 2, 3, 4, 5. Boom, and we have our problem solved. So this is very easy. I mean, eventually you'll be able to figure it out by just brute forcing it. However, how are we going to solve this with code? I mean, that seems almost impossible if we can't see. How do we solve it? Well, here's how we're going to approach this. We're going to use a breadth first search, and we're going to represent our board as a string. So instead of having it in arrays like this, instead we're going to turn it into a string that's just 1, 2, 3, 4, 0, 5. Okay? This is going to allow us to understand, like, okay, these are in the right place, these aren't. Then we're going to use our breadth first search to explore the possible states. So we'll do this level by level. We will then swap tiles to generate new states, and at each step we find the position of the 0 tile, swap it with its valid neighbor, and that will generate a new configuration. We will track our visited states by using a set to store the valid states. So we'll have a set that's going to track the states just like this. So if we swap 4 and 0, we'll have 1, 2, 3, 0, 4, 5. We will chuck that into our set, right? So now we have this has already been traversed, this has already been traversed, and we'll just keep track of all the states we traverse. So using that and how we're going to do that, I think it's best to explore this problem by demonstrating a example walkthrough first. So let's say we started with this board, the example 1 board. I'll scroll up so we can see it better, actually. So let's say I start with the example 1 board right here. We have 1, 2, 3, 4, 0, 5. First thing we're going to do is flatten our string. So we're going to have 1, 2, 3, 4, 0, 5. Our target string, so we'll call it T, is very close to this. So we have 1, 2, 3, 4, 5, 0. So every time we run this problem, we have the target of 1, 2, 3, 4, 5, 0. Our first move. So 0 is currently at index 4, right? So we have index 0, 1, 2, 3. This is index 4. We want 0 to be at index 5. So we can generate a couple new states. We can generate 1, 0, 3, 4, 2, 5, right? Because we could swap these two. Or we can generate 1, 2, 3, 0, 4, 5, because we could swap these two. Or we can generate 1, 2, 3, 4, 5, 0, if we swap these two, of course. So, because we're like, hey now, this is what we're looking for. This is quite literally perfect. We found our solution. And basically how we're going to be traversing this is each time we create one of these secondary strings, like a new version of it, we're going to look and see which one is closest to our target string, and we will proceed to use that one from there. If we traverse that entire possible string and it doesn't get us to our solution, we will go back up our kind of tree, since we're using a breadth first search, and continue off with the second closest one. So let's go ahead and jump into the code for this. So first thing we're going to do is identify the direction map for our possible moves. Because we're going to flatten the string and turn it into a one-dimensional array kind of for ourselves, we're going to have to take that into consideration with our directions. So we're going to have our directions be a 2D array, and we're going to automatically define the possible directions for this move, simply because we know all the possible directions. So the first is 1, 3. The next possible move is 0, 2, 4. Next is 1, 5. Next is 0, 4. Next is 1, 3, 5. Next is 2, 4. So these are all of our possible directions. We can traverse, of course. Yeah. So that is our directions array. Next thing we're going to do is initialize our target. So our string target, we know we need to get to the state 1, 2, 3, 4, 5, 0. And then we will use a string builder called start, so that way we can consistently update our current current set pattern of numbers based off of their position in the game. And we'll convert our 2D board into our string by simply having a nested loop. So for each integer I is equal to 0, as long as I is less than our board dot length, I can increment. And for each integer j, initialize to 0, j is less than board of 0 dot length. If you're doing a hard problem, I'm assuming you know that board of 0 means that we're counting the second, or the columns. And then we will do our start dot append our board of I of j. So that's going to allow us to fill our board. So in the 0 column, we'll get 1, 2, 3, and our in our second column, we'll get 4, 0, 5. And then they will just all append into one string. Next thing we're going to do is create the set. And the set is going to store all of our visited states. So set, we're going to store strings, and we're going to call it visited, is going to be a new hash set. And then we can use a queue, which is also going to have strings. And this is going to allow us to traverse and go backwards if we can't find our target through the current way we visited. So using a queue in a set, the queue is going to keep track of where we're at from our starting point, so we can traverse and calculate the moves. The set is going to keep track of all the visited strings, so that way if we plan on making a move, we could check if it's already in the set. If it is, we will not traverse it again. So we will add our, I like just naming our queues Q, simply because I can't spell. So Q, we're going to .add start .toString to the queue. We're also going to add it to visited. .add our start .toString. So we're adding our starting position, our starting string, to the visited set, as well as to our queue, so that way we know where we're starting, and then we will continue to move from there. We then want to keep track of our moves, so we'll have an integer called moves, initialize the 0, and finally we're going to set up our breadth first search to minimize the number of moves we need to make. So while our queue is not empty, we are going to do the breadth first search. So we're going to have an integer called size, and that will be our queue.size. And while size, we're going to decrease it, is greater than 0, we're going to have our string called current be equal to our queue.poll. So while our size is greater than 0, we're going to pull whatever's at the top of our queue, and we're going to use this to traverse the breadth first search and kind of make the changes to the string to get closer to our target. So if the current dot equals our target, oh my gosh, we did it, we're the best, we can return our moves. Woohoo! But that's not going to happen the first time unless it's already solved. So we are going to get the 0 position. So int 0 is going to be equal to the current dot index of the 0, right? This is going to get the position of the character 0 in our string. And then we're going to use this to kind of traverse and make the new possible strings. So for each integer new position in directions, we're going to pass it our 0 position, and then we're going to have our string next. This is going to be the next state of our string. So new position is going to go through each of these possible positions in our directions array. It's going to keep track of where our 0 position is, and it will adjust the 0 position according to the possible directions it can move. Doing that, we will have our string called next, and that is going to swap the current with the 0 to the new. So it's getting a little complicated now. String next is going to be equal to, we're going to create a swap function. It's going to take our current string, its 0 position, and it's going to swap it using all the directions to create our new position. But, sorry, our new position is the directions. But yeah, it's going to return the next string, which is our new position, based off of each direction that we move in. So if the state has already been visited, we can use our if visited dot contains next. Then we don't want to add it to our queue, so we're going to continue, as we already know that that's not the solution. Otherwise, we're going to add next to the visited, because it is being traversed, and then we'll add it to our queue. So this is, that was weird. This is our for loop that is going to traverse every possible position we can move with our 0 from each place. So if 0's here, we're going to move it left, we're going to move it up, we're going to move it right. So we're going to create 3 new next positions. Each of these next positions is going to check if it's already been visited. If not, we're going to add it to our visited, and then we're going to add it to our queue. So it's going to do that for every new position. So it's going to traverse it every possible way it can, and then add those all to the queue. When we break out of this for loop, we are going to increment our moves. And then if our queue is not empty yet, because we just added 3 new possible moves to our queue, it's going to come back up here, it's going to get the size, and then it's going to redo this. So we're going to start with 1 in our queue initially. From 1, there's at least 1 to 3 possible moves we can make. So it's going to add 3. And for each of these 3 possible moves, there might be 1 or 2 new moves that it can make. So it's going to continue to add things to our queue. So this while loop is going to keep going until all possible moves are traversed. We're going to check if... What did I do here? Next line. We're going to check if our current string is equal to our target. If so, we can return the total moves we made. Otherwise, we're going to get the position as 0 and traverse it again if there's any possible places to traverse it. Because if we've already visited it, we'll skip it. So this will continue until we find either how many moves we make, or we go through all possible scenarios and find that we have to return -1 because there is no possible solution. So that's it for our breadth first search. We still need to create our swap function though. So we're going to have a private. It's going to return a string called swap. We're going to receive a string. We're going to receive a position I and a position j. I is going to be the position of our 0. J is going to be the direction we're swapping it with. So we're going to have a string builder, which is going to allow us to manipulate the string easy. And our string builder is going to be the string str. So it's kind of going to break it down into a manipulable string. String builder dot, we're going to set our character at I with str dot char at j. So we're going to swap these 2 positions. String builder dot set char at j is going to be equal to str dot char at I. So boom, we just swap those 2 positions. Now we can return our string builder dot to string. And it's as simple as that. That is our swap function. So now if we return, or if we run this, this passes our test cases, and if we submit it, this passes all solutions, beating 97% of people. Yeah, this shit was hard, but we did it. If you want to learn how to code with me today, check out the link in my bio. You'll be able to solve hard problems like this easily. I mean, it's obviously not an easy problem, but you'll be able to understand the concepts better. Anyways, thank you. Follow for more daily LeetCode solutions, and check out the link in my bio. I promise you will not be disappointed.